Hello students, welcome back to CLARI Concepts, Unleashing the Conceptual Learning. For more lectures, you can visit our website www.clariconcepts.com. So we will continue our series of Newton's law of viscosity and the numerical examples. So this numerical example is little tricky and I would request you to pay a close attention to this. So I have two large plane surfaces two large plane surfaces are 2.5 centimeter apart. The space between the surfaces is filled with glycerin. So they gave you two large surfaces and they are 2.4 centimeter apart, and the space between these two surfaces is filled with the liquid called glycerin. What force is required to drag a very thin plate of surface area 0.5 meters square? Now see, just a minute. Let me take the pen. Okay. Now you need to understand this very clearly. What force is required to drag a very thin plate of surface area 0.5 meters square between the two large plane surfaces at a speed of 0.6 meter per second. So they said that two large plane surfaces, glycerin is filled and the small thin plate is filled between these two surfaces, which is having area of 0.5 meters square, and it has to be dragged by a velocity of 0.6 meter per second. In first case, if the thin plate is in the middle of the two plane surfaces, and in second case, the thin plate is at a distance of 0.8 centimeter from one of the surfaces, right? And you have been given dynamic viscosity of glycerin as 0.81 Newton second per meter square. So first, let me draw the diagram. So let's say, for example, if I talk about case 1, if I talk about the first case, which is this one, where the thin plate is in the middle of the two. So let's suppose I have the two large surfaces. This is surface 1, surface 2, right, and both of them are separated by a distance of probably given to you as 2.4 centimeter, right, and you have a thin plate in between which is exactly located in the middle of this, a thin plate located in the middle of both the plates. So you can say that the distance between these two is half of this, so 1.2 centimeter, and distance between these two is also half of this, 1.2 centimeter, right? And this plate is to be dragged with the velocity of 0.6 meter per second. Now see, both of these plates are fixed. This is also fixed, this is also fixed. Now if you try to see, they are asking you to calculate the forces. See, they are asking you to calculate the forces. That forces that is required, what is the force required to drag this plate? So you need to calculate the force that you will need to apply on this small, very thin plate. This value of force will depend on the resistive force offered on both the side by both the fluids, right? So let us suppose the resistive force offered over here is F1 and resistive force offered over here is F2. Now if you try to draw the velocity profile on bottom portion, you will see like this. We will assume a linear velocity profile again. Similarly, on top portion, if you try to draw the velocity profile, you will get like this. So if you want to find the resistive force, so I can say that the total force F will be equal to F1 plus F2. Looking at the diagram, it is symmetric as of now, right? Symmetric meaning both the sides the force is going to be the same. So first let us try to find out what is the value of F1. In order to find what is the value of F1, I need to apply the Newton's law of viscosity on the top portion. So that will be tau equals to mu du by dy. Yes. Now in case of linear velocity profile, I can replace du by dy with respect to v by L. So tau will be equals to mu v by L, isn't it? Now since it is the top portion, the upper portion I am representing it by number 1, I would say tau 1 is equals to mu is the same. V is the same, V by let's say L1. L1 is this 1.2, right? So in this case, I can say F1 divided by area equals to mu V by L1, and therefore I could say F1 should be equals to, I'll just put the values. What is area? Value of area 0.5 meters square, right? Then what is value of mu? Mu is given to you as 0.81. Then value of velocity is given to you as 0.6, and then value of L1, which is 1.2 centimeter. So that means in meter, if you want to convert, you will divide it by 100. So this will be 0.012. Now simply calculate the value of F1 that you will get from here. So let me just use my calculator to find out the answer. This is 0.81 into 0.6 divided by 0.012 multiplied by 0.5. You will get F1 to be 20.25 newtons. Now if you use the same equation for the lower half also, and you will get that F2 is also equals to 20.25. The same answer, because it is the symmetric in both the sides. So that means your total force F will be equals to F1 plus F2, which is equals to 20.25 plus 20.25, which is 40.5 newtons. So this means answer number 1 you have already identified, that for the first case, when plate is had at the middle of this two large plate, the force required to pull the plate by a velocity of 0.6 meter per second is required, is equals to 40.5 Newton. Let us now talk about the second case. Case 2. In case 2, we have seen that between the two large plates and over here, right, this distance was given to you as 2.4 centimeter, and the plate which is mounted is that on one of the sides, right? So somewhere over here, this thin plate is now no more in the middle, it is located at somewhere nearby one of the boundaries. So let us see. So what is there saying? The thin plate is at a distance of 0.8 centimeter from one of the surface. That means what? They said that this distance, let's say the top one is 0.8 centimeter, which means what? What could be the bottom distance? 2.4 minus 0.8, this will be 1.6 centimeter. Yes. Now here the force required is, let's say, F, and the resistive force is, let's say, F1 and F2 on top and bottom side. Now here F1 and F2 will not be same because the plate is shifted from the middle, right? So let us try to find what is F1 and F2. So for first, F should be equals to F1 plus F2. Looking at the free body diagram of the thin plate, what is F1? Now if I apply, let's say, the Newton's law of viscosity on the top half, I'll get something like this, isn't it? This is the velocity profile. And if I apply this on the second half, I'll get like this. So firstly, I'll apply the Newton's law of viscosity in the first half. Tau 1 will be equals to mu du by dy at 1. Assuming linear profile, tau 1 is equals to mu v by L1. Tau 1 is F1 divided by area equals to mu v by L1. So now put the values. F1 divided by area is 0.6 meters. Let me just verify. 0.5 meters square, sorry. So the area is 0.5. Mu is given to you as 0.081. 0.81. Mu is 0.81. Velocity is just verify it one more time. 0.6 meter per second. 0.6. And what is L1? L1 is the distance between these two. That is 0.8 centimeters. So if you convert this to meter, you will get 0.008 meters. So now simply find out the value of F1. 0.81 into 0.6 into 0.5 divided by 0.008. This F1 is coming out to be 30.375 newtons, right? Now let us calculate F2. What is F2? F2 will be equal, simply you use the same formula. F2 by area will be equals to mu V divided by L2. So F2 divided by area is what? 0.5. Area of the plate, right? Mu is what? 0.81. V is 0.6. And L2 will be different. L2 is what? 1.6 centimeter. You divide it by 100. 0.016, isn't it? So now you calculate the value of F2. 0.81 into 0.6 into 0.5 divided by 0.016. Sorry. 0.81 into 0.6 into 0.5 divided by 0.016. This F2 is coming out to be 15.1875 newtons. That means final total value of force is F1 plus F2. F1 is 30.375 and F2 is 15.1875. You add both this, you will get F to be equals to 45.56 Newton. Answer number 2. So you see, which means if you compare it with the previous case, when the plate was in the middle, the force required was 40 newtons around, and now when the plate is shifted nearby to one of the surfaces, the force required has increased 45.56 Newton. Let me check the answer. Yes, the answer is perfectly correct. So I hope you understood this example, how to solve this. Thank you so much. We'll see you in the next class where we will talk about another numericals and all. Thank you so much.